It's my distinct pleasure to introduce Steve Rader. Steve and I have worked together for a ridiculously long amount of time now on a variety of command and control systems. And Steve's talk today is rather interesting to us. It's going to be on the power of the crowd to solve problems and to develop systems. Really looking at new and innovative ways for us when we're starting to talk about how do we develop some of these systems that, for us could be applied from anything from our very, very simple ground systems to our much more complex subsystems. So interested in hearing about that. A little bit of background about Steve. Steve currently serves as the Deputy Manager of the Center of Excellence for Collaborative Innovation. It's a long title, I like that title. He has a mechanical engineering degree from Rice and has worked at NASA's Johnson Space Center for about 25 years. Over that time, he's been involved in mission operations and flight software development for the International Space Station, command and control systems for the X-38, which I still wish was flying, and most recently, the C3I architectures for the Constellation program. So please join me in welcoming Steve Rader.
Well, hi. It has been a while since I've been at GSAW, but I actually have been here quite a bit over the years. I'm going to talk to you today about a few things. First, I'll talk a little bit about what crowdsourcing is and some of the background behind that. And then I'll talk a little bit about what NASA is doing with that. This is a dramatic pause for you two. There we go. So first off, what is crowdsourcing? How many of you would say you're familiar with crowdsourcing? Okay, I'd say that's about a third, maybe a half. Crowdsourcing is one of those really interesting areas that started to develop over the past few years. I became interested in this about 4 years ago. I read Jeff Howe's book on crowdsourcing that my brother at IBM gave me, and it really opened my eyes to what's been happening around us in the world with regards to this. Jeff Howe is editor at Wired Magazine. He coined the term crowdsourcing, wrote a really nice book, and it talks a lot about some of the research that's being done on this and the platforms that are emerging. But crowdsourcing really comes down to this idea of using the unique power of crowds that we now have because they're connected through the internet. Things that we couldn't do before. And you can use that crowd to solve problems, to perform tasks, to raise money, a whole host of things, and I'll talk through some of that. The sheer number of people is key to this, and you can really tap into a lot of different pieces. But they respond to a bunch of different incentives. We'll talk through that. We'll talk about the fact that you can do some massively parallel work with them, which can get some really nice results. They can actually provide really high quality, and that's maybe a surprise for you, and then provide a depth of expertise that you may not have in your own company or your own organization, and they can provide some real innovation. I'll talk a lot about that. Bill Joy at Sun Microsystems said, no matter who you are, most of the smartest people work for somebody else. And you really should let that sink in because it's counterintuitive to how we've worked in the past. We've worked very hard to collect some of the best people on our teams and to be the best. And crowdsourcing is really opening up this avenue to where in our toolbox of things is access to people much smarter than we are on our team. And so we have to be open to that. Okay, not sure why that disappeared. This is my old version, by the way. Which is fine. No, it's fine. It will all go really smoothly. This is a chart I got off of crowdsourcing.org, which is a great clearinghouse website that talks really the scope of crowdsourcing. I've got a couple of these charts. But if you think crowdsourcing is new and one of these cutting edge things, you ought to think again. Because each one of these icons is a different company that is out there working. And they work in a variety of areas, in crowdfunding, in tool development, crowd labor, open innovation. And you can see there's a bunch of these infographics. They really handle a lot of different areas. And so it's kind of hard to talk about because there are so many different aspects to it. Some of them are about innovation and coming up with new ideas. Others are about getting work done on the cheap. Others are about raising money, etc. So we'll talk a little bit through those. If you think about your organization, you hire the people that you think are really well fit to the problem. And in your community, you have even more people that are your subcontractors or your communities of practice. But then there's this long tail of other possible people out there. And crowdsourcing allows you to tap into some of that. The crowd is growing. This actually shocked me a little bit. The blue is the number of people in the world by continent on the internet, connected on the internet in 2001. And that number was around 360 million people. And in the 11 years after that, that number rose to 2.4 billion people. So you can see in the North American area, we've over doubled, right? We've over doubled the people that are connected to the internet. We're about 80 some odd percent of North Americans. And so we can grow another 20% and get everybody in North America on the internet. But in Asia, they're only at 28%, and that's this tall line. So their number goes up another twofold before it runs dry. You can really start to see the capacity here. And what you ought to be thinking about isn't, well, some of those people are farmers and some of those people. When the aggregate numbers go up, the number of capable people on it goes up as well. And so the number of resources we have to draw on goes higher and higher. Okay. What incentivizes the crowd? Why do they contribute? It's really for a number of reasons. Sometimes it's for money, and you can put prizes out there, and we do that a lot. Some, it's actually to have fun. Anybody heard of Fold It? Anybody? Fold It was a gamification that the medical folks came up with on protein sequence folding. So there's this whole pattern thing, and it was a game. Ends up the best protein folder in the world is this like 8-year-old girl who's like now responsible for all these advances in medicine because of this game. Some do it to socialize with others, and I'll talk a lot about really well-formed communities that provide a win-win for the community. Others are to get recognition, prestige. This is really big in some of the technical areas. People want to be the person for this particular technical area. And then there's a lot of do-good stuff. People trying to make a difference in the world, especially with the newer generation. That is their focus. They want to make a difference and help folks in need. Sometimes it's learning something new. A lot of these platforms have experts that can mentor and do mentor folks that are trying to learn. Great example of that's like iPhoto or iStock Photo really changed the whole photography industry. And it is largely a website dedicated to helping photo enthusiasts learn their hobby. But they've turned that into an entire industry. Obtain something else, create self-serving resources. All of these multiple incentives can be put in parallel. For NASA, we leverage these things all together, but because we're NASA, we have the geek factor going for us. I mean, people love to come and help, create the next space thing. So we can give away T-shirts and get things where somebody else had to post a $1,000 prize. Well-formulated crowds really work best. And these are crowds where the platform or the company behind it is actually organizing the crowd in a way that they've got passionate enthusiasts who are getting a win-win out of this. People who are learning, who are being supported, and not just being manipulated and being used for what they can give you. And we're seeing those really successful in a number of ways. Let me give you an example. We met with a company the other day called GrabCAD. Anyone heard of GrabCAD? GrabCAD started as a CAD model sharing platform. People would make a 3D model, they'd put it up on here, they could store it there, they could share it, they could show other engineers, they could collaborate, there were some collaboration tools. That community is now up to 2 million users, mostly engineers. It cost $2,000 to run a challenge on there. You can say, I need I saw one the other day, it was a bumper for a truck, right? We want a lighter, stronger bumper. We're offering $1,500 in prize money. They had 50 submissions by engineers going for $1,500, designing the next generation bumper. Virtually no cost. At NASA, you could put that on a credit card, $3,500 credit card. You could get an entire challenge, get fully functional models, get the IP transferred to you, and go use that CAD model. Some really interesting stuff. So what kind of models are there out there? There's microtasks. Amazon has something called Mechanical Turk, where you can go take a task and you have something you need done, a database populated with scanned information, a translation, something where you're trying to transcribe work. We did some work on desert rats where we wanted the crew conversations transcribed. You can do all that kind of stuff where the platform will chop up your work and hand it out for 10 cents for every 5 seconds of transcription they do. And a bunch of people all over the world do that, and you get it back in a week, and it's all done for $300. Co-creation, open innovation contests, we do a lot with that, and I'll talk quite a bit about that. That's along the X Prize area in incentive. I'll talk a lot about incentive. Predictive markets, I've talked crowdfunding. The gamification I mentioned with Foldit, transparent, social engineering, or social search and polling, and physical interface and tasking. There's actually people out there building things with crowds, physical things. Okay, so that's the overview of the crowd and what it can and could do. So what's NASA doing with this, and why is NASA doing this? Well, if you noticed, the world is going this way. This is not something where we're off in a corner saying, hey, this is something new we should try because it might be big. It is big. General Electric, Procter & Gamble, they're all jumping on with this stuff and using it effectively. Not for everything. Let me say that again, not for everything. They're finding the places that this can be used effectively and adding it to their toolbox. So, about 2 years ago, the White House came to NASA because NASA had been doing some benchmarking and some experimentation with this work, and asked if NASA would set up a center of excellence for collaborative innovation that would help the rest of the government get started in this. And so I work in that office, I'm the deputy manager, and we work within NASA and across all of the federal agencies to try to understand. So we do a lot of research in our organization. We partnered with Harvard on some of that. And we work basically to see what are the best fits. We do a lot of trial runs. We're trying to get other organizations to understand the contracting mechanisms behind it, how IP works, how the actual platforms work. And in fact, we'll have a BAA coming out shortly where we'll actually be expanding the number of contracts we work with. Right now, we have 3 main contracts in place with 4 different platform options. One is the NASA at Work, and that's with Incentive. Let me talk first about what Incentive is. Incentive is a rather large technical platform where they've got, I think it's 400,000 technical folks. And when I say technical folks, that's engineers and scientists in all of the disciplines. But it's really anyone who wants to sign up. It's totally open to the public. They run largish prize type challenges. If you get on incentive.com, you can actually look up, and military has a bunch of challenges on there. We've got a bunch of challenges on there. Industry has a bunch of challenges, and they range anywhere from we need to take this particular chemical compound and make it soluble in this chemical compound, and we don't know how to do it, all the way to I need to get grease off of potato chips. The interesting thing about incentive is Kareem Lakhani at Harvard studied a lot of their results, and they've got extremely good results at putting problems out there and getting them solved. Almost, I don't know what their percentage is, but it's a very high percentage of posted challenges come up with solutions. These are problems that companies are having that their folks can't solve. So I'll give you two examples from that industry. One was potato chips. I just said that right. They wanted to get grease off of potato chips. I forget which it was Frito-Lay or somebody. And the person that solved that challenge was a violinist who had observed that the rosin comes off of their bow at certain natural frequencies and said, I wonder if that would work for what you're trying to solve. That's now how they do that. The studies show that something like 75% or better of the innovations that come from people not in the discipline. So if you have a chemistry problem, chances are your big innovation's not going to come from somebody in chemistry. Because all of those people have been thinking about the same problems the same way. And it takes that outside viewpoint where somebody that's had this nexus of experience and training that happens to come together around your problem. And that's where innovation statistically seems to be coming from. One other example that I love on incentive is there was a kind of bio firm working for about 20 years on various breakthrough bio work. And they had 6 or 8 really good breakthroughs throughout their career, and they were working on their next big one, couldn't crack it, put it out there as an incentive prize. I think it's something like a $60,000 prize. And in 6 weeks, not only had the next big innovation been solved, but all of their submissions actually reproduced 20 years of work in that lab. So there's some power out there. So we use incentive for 2 things. One is we use their at-work platform. They actually have a platform that they'll set up internal. So we at NASA have something called NASA at Work. The idea is that your employees are a crowd, and you can actually have them work for a lot less than other folks. So we started with $200 prizes for NASA because that's the way NASA prizes work. Sequestration actually caused us to take those prizes away because prize money gets pulled off the top. And so now we actually offer cool NASA experiences and tweets from astronauts and things like that. And it's actually a bigger incentive than the $200. And so we've got about 150 awardees so far. We're coming up on our 150th. Really good platform for actually sharing information across your organization. We've got 10,000 folks, registered solvers at NASA. NASA's about 68,000 total NASA and contractors. We've got about 32% of the NASA crowd, about 10% of the contractor crowd contributing. And what's interesting is that they are actually helping to share information. So somebody will say, hey, I need a way to detect leaks in this piping system. And somebody over here will say, well, we've done that. But they're over at another center in another organization. And if you're in a big organization, you know that's one of your biggest problems, is how do you get folks to talk? Challenges tend to be a great way to do that. So we work that. That is free for our NASA users. So we have a contract where we cover that. But we make, for the projects, we make that a free thing. If they want to post a challenge, great, they can do that. For $5,000, they can get consultation on how to better formulate that. We also use the incentive platform, and I'll show a couple. I'll show examples on all these for the outside challenges. This is where we use their 300,000 solvers from around the world, and they're a bigger deal. So we'll put out a $30,000 prize or a $50,000 prize around cosmic galactic ray problems or whatever. And that's at the NASA Pavilion within incentive. We also use TopCoder. TopCoder is a software and algorithmic development house. I will talk quite a bit about them. And then the last one, I won't spend a whole lot of time, it's called the yet2.com. We have contract with them, which is really a tech scouting. That's where they actually have a lot of connections between companies, have insights into their intellectual property. So when we have tech needs, they can actually match make. It's kind of like the match.com of technology. So I'll talk a little bit about that. And then finally, the Centennial and Grand Challenges. Grand Challenges are interesting. That's out of Jen Gustetic and Larry Cooper at headquarters office. And what they do is these larger prizes. So a good example of that was the Green, and let me get my notes here, the Green Flight Challenge. Is anybody familiar with the Green Flight Challenge? It just wrapped up, I think, a year or so ago, or last year. And it was a challenge to make a 4-seater aircraft that could travel basically at 200 miles per gas equivalent, gallon of gas equivalent for every passenger, okay? Or 100 for half a gallon equivalent. The interesting thing about that was a $1.5 million prize. There were about 6-7 teams that participated in that challenge. Of that challenge, 2 achieved the goal of the challenge to actually provide that efficiency in the aircraft. The thing about it is the winning team beat it by a factor of 2. The total that all of those companies put towards that challenge was $6 million. So for a $1.6 million prize, we got $6 million worth of R&D and prototyping and research. And it was a win-win because each one of those firms developed their own technologies, their own pieces of that, so it wasn't wasted. They were able to go and sell what they did, but also at NASA we got huge advances in the state of the art. So there's a whole ongoing set of these. I think the latest one is a $1.5 million challenge for a planetary sample return robot. That one, I think they've awarded like a 5K prize so far at the first stage where somebody met like the first 3 requirements and they've got another 25 to go to get the $1.5 million prize. Okay, NASA at work. I've talked quite a bit about this. Again, we've awarded 150 folks with 50 challenges awarded. We do multiple awardees. A lot of pilots. I've talked about the alternative prizes. This is what the platform looks like. It's very simple. We simply put a problem statement out there. You can go get more details, and then we actually have discussion boards where folks can discuss that, and from the discussion threads, we actually pull the winners. Very simple. I will say there are multiple platforms out there to do this kind of work. Brightsmith.com has a great platform that lets people compete in real time, get awards, and rate each other, and it's a little more competitive. But there's multiple of these platforms. A good example here, we actually put a challenge out to have alternate design material approach for the electron radiation protection. For that, we had 3 participants from 2 centers. And let me talk about that for a second. We have 10,000 people registered. We got 3 participants. That is perfectly okay because the emails went to all 10,000. And what you're looking for is the crowd to self-select. And then so we self-selected 3 participants that happened to be experts in this area and had answers for us. And so we ended up with 12 discussion posts. We had a solver from Goddard and another solver from Johnson. One had a very detailed description of how to use the use of tungsten dust. The other actually provided us historical information about what we did in Apollo. The challenge owner, said it was really useful and would do it again. Okay, moving on to the innovation platform and incentive. We ran a whole host of initial challenges on this. We tapped in 2,900 solvers from 80 countries. Our pilots, we had, I think, 7 different pilots here. All I really want to show from this table is that the majority of these ran for about 6 weeks. We ran that in multiple centers, and our awards ranged anywhere from $7,500 all the way up to about $30,000. But short periods of time, relatively small amounts of money. We were successful on all but one of those. The one we weren't successful on was the laundry system. We learned a lot from that in that when you make a problem too broad and put it out there, complex systems are very difficult in these kinds of platforms. You have to have the right level carved out. So NASA had a challenge where we wanted to drive from the data, from solar data that we have coming in on our sensors, the ability to forecast solar events. Obviously, this is important. We have space station up there. We also want deep space travel, so we want the capability to protect crew members. And previous work to extend this prediction capability to beyond 1 to 2 hours had not been successful. So it was kind of last minute, hey, stop what you're doing, go hide in the special parts of the hab. The challenge was to extend that to a 4 to 24-hour prediction and get a 2 sigma confidence interval. The result was that we got an 8-hour prediction, considerably better, with 85% accuracy and a 3 sigma confidence interval. Ended up, this guy was a radio frequency engineer, retired, happened to have all the right experience, provided a fully functional model as the result. And in fact, this was like a, $20K award. The interesting thing about this had 3,000 participants, 95% of who had never participated in NASA with anything. So if you think about engaging the public, which is one of the things we think is really important to do, crowdsourcing starts to be a way that we can do that in meaningful ways. Okay, I have the most on top cover probably because we're really engaged with them right now, but I can go through that. How am I doing on time? Pretty good. Okay. First, top coder really breaks up the problem. So if you, their big items are algorithms and software. And what they do is they break that up into lots of little contests. So a challenge might be to develop a mobile app that taps into a backend to give you a map that shows you cyanobacterial growth in ponds. So that's the challenge we're doing with EPA right now. And they have about 600,000 plus software developers from around the world. And their community is dedicated to try to making that cheaper and faster and better. And so right now we get about a 20% cost of what it would normally be by using Topcoder. Okay, their big thing is micro tasks and crowdsourcing, so they break it all up. And then they also have ideation and open innovation similar to what an incentive can do. Just keep in mind, your crowd for Topcoder is software developers and algorithm folks. So it's the super nerds. Over in the incentive crowd, it's nerds, but not quite to this. It's different kinds of nerds, right? So the community composition is a big deal, right? I would say if you're trying to get innovation in an algorithm and different approaches to doing an algorithm, this is a great platform. If you're trying to get innovation around a general problem, like radiation or something, in a sense, the better way to go, right? So you always want to look at your crowds. And in fact, under the BA, when we start to get more and more firms in, we hope to really start getting a broader set that we can start understanding. Okay. This is interesting because software development is something I think a lot of you have on your plate. This platform actually can do the full software development lifecycle. They can do full development, assembly, testing, bug races, architecture, but they can also do the conceptual design, the wireframes, the storyboards. I'm actually the lead NASA person on the EPA task, and we've got them developing this mobile app. And they came out with the wireframes for it, which the wireframes are kind of a prototype clickable interface that show you what it's going to look like. They showed us 8 different designs and said, tell us what you like about these and what you don't like. So we'd go through, I like the config screen on this, and I like the map on this, I like the color scheme on this. And then they turn around and have those competitors reassemble it just the way you like it. Now, I don't know about you, but in my software development house, we have one guy that does UI, maybe 2, and you go through endless meetings trying to figure out what you're going to do, and then you finally get something, and then it gets tweaked. But you don't get this kind of thing where you get, 7, 9 different prototypes all coming together. Very interesting stuff. Don't know which screen to look at. They also do a lot of algorithm work on the marathon matches and single round matches. Those are just ways that they can take and improve algorithms or come up with algorithms based on data. So for instance, we're doing one called Quake Finder right now. And Quake Finder is trying to take magnetometer data at various sensors around the world and actually find quakes, okay? And it's a totally new approach to dealing with earthquakes and how we do it. USGS doesn't like them because they're doing it differently. And these guys are actually just handing them data and letting the algorithm folks do what they do. And it's really interesting because when we've done this on several other projects, you get multiple approaches. In fact, I think that's one of my examples coming up in a second. So they can do mobile apps, websites, e-commerce, platforms, strategic assets, legacy integration. People talk about sustaining and all these kinds of issues. One of the examples they gave was they had an accounting firm that needed COBOL development, right? Who knows COBOL? Really? In their entire multi-million-dollar community, they had 3 people that knew COBOL. Say again? Laser pointer, did I point it at you guys? COBOL. What they found is barely anyone did COBOL. And they then put out this problem of we need to fix this code, and it's COBOL. Ended up their winners, none of them were of the folks that knew COBOL. They were able to make the fix, make it quickly, but they did that by learning COBOL because it's just another programming language. So these guys you don't have to worry as much about how can they handle it, how can they understand it. These guys dig in and just do the job. Okay, analytics, talked about. I'll speed up a little bit here. Who's familiar with Comcast's home automation system? I think it's called Xfinity. Really? You guys on billboards for that around here? That was actually totally developed by Topcoder. And if you think about it, that was a highly proprietary system that Comcast did not want folks to know how it worked. It took 18 months, people from 21 different countries, 500 people, and they ended up deploying, I think, recently. And it does whole home automation through their system. At NASA, we've done a number here. We did a food intake tracker app that we're working on the final stages of getting it flying on space station. Pipeline protection, it was a detection algorithm that had to distinguish between normal vibrations of squirrels and deer in the woods and a vehicle driving up to a pipeline. Planetary data system, I think a lot of you are familiar with that, trying to work on better APIs and get people access to it. And then space station. The Longerons that turn the solar rays on the space station, actually if they're half in shadow and half in the sunlight, can torque over due to the temperature difference. And so there's a lot of planning that goes into making sure that that doesn't happen. And so we put that out, put some models together. We had 4,000 plus registrants, 450 submissions, all for a $30,000 prize. Ended up with a model that was as good or better, and as good on the bulk cases, much better at the edge cases for predicting how the solar array should be done. I want to hit this one real quick. Algorithms. This is where they have some of the best people in the world, and I actually got to meet a few of them at the Topcoder Open. This was a antibody sequencing algorithm that existed in the research community called Megablast, and it took about 15,000 seconds to run. It had about a 0.72 accuracy, and that's what they had. Now, in the study, they went ahead and took a couple of grad students, paid them $120,000, and over a year, they increased the performance of that to this blue area. About an order of magnitude performance increase, and they increased the accuracy to 0.77, all for $120K. A 6K challenge running 2 weeks on Topcoder got all of these solutions right here. The winning solution increased to 0.8 the accuracy and increased to 16 seconds. the performance of that algorithm. In that, they had 120 coders submit 654 solutions. So each of these guys are generating multiple solutions. 89 different approaches to the problem. It is really huge. And then they had 5 winning countries, 5 winners in different countries. So really amazing, and we've kind of seen this over and over. I was at the Top Code Open where they would compete these guys. They would give them 3 algorithms to do in an hour and 45 minutes to figure out from scratch, here's a problem statement. And to watch these guys is just amazing. The Top Code Open, by the way, is where they, once a year, fly in their top 100 coders from around the world out of this crowd and have them compete in these really nerdy contests. It's great. The kind of things they're doing is these algorithm optimization, these clustering predictors, graph-based analytics, nonlinear combinatorial optimizations, image patterns, things I have no idea what they are. Software development lifecycle we've talked about. The interesting thing is how they perform as well. One of the things they do is they have what's called a co-pilot. Co-pilot is a project lead who is a community member. The company itself has a very small staff, and they actually have a set of community members, and they track everything about these community members. How many times they've attempted a problem, how many times they've solved it, how many first place, how many second place, how many algorithms versus how much testing, how much. They know everything about these guys, and they pick the top echelon of these guys that are good at project management and put them in charge of these contests. And they formulate them, they do budgets, and in fact, they'll even sometimes have contests where they'll say, give us the best project plan for this problem, and they will compete project managers against each other to see who will come up with the best project plan. Think about that. Think if you did that in your organization. Once they get them, they can actually have multiple areas that are working in parallel. They can get co-pilots working in the UI design and in the algorithms part, all in parallel and working a lot faster. Okay, yet2.com, I just flashed this up there again. This is a dating service for technology if you want to think about. There's one that works the other way called Marblar that we don't have I think Marshall actually has a contract with them right now. And that is actually taking your technology and handing it over for folks to figure out where it's best implemented, which is the opposite of this problem. Here's just our scouting results. You can see we put bone density measurement, monitoring water for biocides, things like that. And we get literally hundreds of initial hits that then end up in a handful of leads, which then end up in just a small handful of places to go focus on relationships with the vendor. So really an interesting area, a little bit different in the crowd world. Okay, current paths and what we're doing. Right now, we've got several projects in work, both outside of NASA and within NASA. Within NASA, we're working in the disruption/delay tolerant networking protocol area where we've done some interoperability testing. We've done some development of the LTP authentication code. That code's about to be folded back into the ION code base. And then we're actually working an ideation or an innovation challenge around the key management problem. If you're in security, you know how hard it is. If you do not have good links with all of your endpoints, how do you keep your keys distributed? How do you deal with that problem? That's being worked right now. Actually, there's some really good solutions coming in right now. If you're familiar with Byzantine generals, you'd love all that. Kaboom is a K-band phase uplink array for several things, but one of the things for searching for asteroids using radar. We're looking at doing an algorithm there in the next few months that schedules those. Quake Finder I mentioned. Asteroid identification is actually taking imagery from telescopes, having crowds of people identify asteroids, using that identification to train a machine learning algorithm. It's really interesting. I mentioned the BAA. A lot of that will be around applied research in this area, but again, you have to use these folks to understand how they work and how they're most useful. Closing thoughts. Crowdsourcing really provides this new tool set for problem solving and for system development. think of other places for it, but that's where we're seeing most of our work. It is a large and varied tool set. It is not a one size. It was interesting, I was working with the National Institutes of Health, and it was interesting, I watched, they had a big management meeting, and they were talking about crowdsourcing, and the concerns that were being voiced were very specific to patient privacy data, things like that. And it was clear that that group didn't understand just the full depth of the problem in the solution space. Really, there are lots of different piece parts to this that you have to understand. Crowdsourcing is not free labor. You can often access really good folks and you can access expertise, but when you actually manipulate them and say, hey, give us something for free, they always revolt. When applied correctly, crowdsourcing can access amazing innovation. Not every time, but if you think about innovation, I don't know about you guys, but we have innovation programs at our center, and everybody just kind of, anytime Innovation Day comes up, they roll their eyes because they know it's just a big song and dance. This is the first time I've seen innovation with tangible, reproducible results. And the problem is we're all engineers. We want to solve problems. So the idea of actually us formulating a problem for somebody else to solve is not our comfort zone. But I thought it was interesting. Einstein had a quote that says, if you give him an hour, gave him an hour, he's dead, to solve a problem, he would spend 95% of that hour, 55 minutes out of that hour, defining the problem, and or 5 minutes solving the problem. And I think that's kind of where we have to get to on our real innovation. We don't think about where our innovation possibilities are a lot of times because we're so concentrated on getting systems built. Okay. When applied correctly, it can provide cost-effective solutions, and it also gives us an opportunity to engage the public in ways that we just haven't been able to before. Engaging the public is more than showing them the cool things that you're doing. Engaging the public is getting them in as part of the team. Okay, that's all I had. So, if there are questions, did I make it through okay? Two minutes for questions. Apparently I do a horrible time management.
So I'm real curious about
The money side.
Yeah.
If there's more than one good answer, do they all get some money, or does just the winner get
Right.
some money? Or?
We work it both ways. Typically, it's very important to define what your criteria are for winners. And typically there's a threshold of it does all these things, and then you also want a performance piece in there that can be measured against them so that you have a clear winner. Typically, if they meet the objectives, like I talked about the airplanes where one was, two actually met the objectives, but one was twice as good, they got the big prize, but there was still a prize for that second winner as well. So we often do that, and a lot of that, there's some science that says it's a good idea to have the possibility of multiple winners, because then it's not a winner-take-all, and you get more participation that way. That's actually one of the things we're studying quite a bit through Kareem Lakhani at Harvard Business School is how do you set prize amounts? How do you make that work? What's the right mix of money, incentives, time? You don't want to give people too much time. You don't want to give them too little time. There are studies that show if you offer $1 million prize for something that should be a $10,000 prize, you will get worse results because people will stay away from that. I actually watched a great one where at the beginning of the DTN project, they wanted just a simple glossary of terms, because we at NASA use a lot of acronyms and weird terms, right? $40 prize. They had 2 contestants. They paid them both $40 because they gave them a fully done glossary in less than 24 hours. It's the right price at the right time, and that's what you want your vendor to really understand is their crowd, how to set their stuff, and then you don't have to try to work all that.
Yeah, I saw the thing you had where it broke down into a lot of these smaller projects.
Mm-hmm.
But that sounds good, but how does this all get integrated back together? Because, I mean, you have a large, system. How
Right.
does that get put back
Right, well,
together?
they have integration contests. They actually, once contests are done, they actually have then contests to integrate. They have very good architecture. Top Coder particularly focuses on interface definition because they know the integration is the hard part, and so they pay particular attention to that. Also, they have a one of the most rigorous testing pieces I've ever seen. They do a lot of stuff in the cloud, which is great as a customer because then you get handed all these scripts that then you can just propagate with virtual machines in the cloud to do all of your regression testing and the rest. Yeah.
Certainly a very fascinating talk. Thank you very much. So my question is, how do you avoid Trojan horses?
Yes. I was like, surely there's going to be a security question. There's a number of ways, and it depends on the platform. One, this is all open code. They only deal in source, so there's no compiled code. And typically they have trusted members that they will assemble to reduce. They have review boards that go through all the code. But remember, it's competitive. So you can have competitions that say, go through this code and find anything that you think is unnecessary or malicious or the rest. And you've got some of the best folks to do that are incentivized by different, and often they'll partition those people from the people competing. And so there's a lot of that goes on. But you know, I did software development for quite a bit of time, and I would say the steps that they do are considerably better than the steps we do. Now that could say something about the way we did, but they just, you don't have the resources necessarily to go through and do the kind of code reviews, to do the kind of testing. They also use quite a bit of automation for some of that too, scans and whatnot. But yeah, security, the two big questions I get and negatives that automatically people go to are security and sustaining engineering. And I will tell you, Comcast Xfinity systems are a good example in the commercial world where clearly those two things were important and are being handled well.
I have just a simpler question, and that is that you mentioned several sites. One was GetTo.com, which I think I understand, and the other one was Incentive, and there was a NASA pavilion in
Incentive. I didn't understand if
Yeah.
Incentive is a NASA
No.
website or
No.
NASA is part of Incentive.
Right. So Incentive is a standalone firm. We have a contract with them. What they do when companies come on board, especially if they have if they want to aggregate the challenges around that brand or that theme, they pop up a pavilion, which is really just a sorted list or a filtered list of your challenges, and that's what they call the NASA Innovation Pavilion. It's really just the collection of NASA challenges on the Incentive site. Good question.
I have a concern about, and maybe not a concern, but how do we manage the disruptive nature of the pipeline of science, technology, engineering, and math students when you tell your son, go get an expensive education and then join the crowd? Because you're going to be competing not in a job, because all the engineers are not going to have full-time jobs. They're going to all be competing against only the best in a competitive market. So how do we manage that socially disruptive element?
I would get paid a lot more if I could answer that fully. But well, it's a great question because this is, you're already doing it, right? We're already competing with each other for jobs and expertise, but we're doing it at a macro level, right? And this is much more of a direct democracy, if you will. It's a direct free market, right? And the direct free market, unfortunately, when you're in the US and have the high-paying jobs, right? Suddenly now you're competing with folks that have a much lower standard of living around the world that don't require as much money. And say again?
We have minimum wage laws.
We do, absolutely. And really it's going to be a growing pain of the global equalization that will ultimately be what evens all that up and stops any anxiety.
It could upset the apple cart in terms of diminishing our position, our strategic position globally.
Yep.
And so I think we have to be very carefully how we tread with this.
Yeah.
We really do need some social scientists to study, and we need to manage
Yeah.
the way government, here's a suggestion, let's lay off all the NASA employees, have a few people coming up with a problem definition.
Yeah.
You don't need a job.
I totally understand. It's like with anything else disruptive. The thing we don't want to do is pretend it's not there, right? And so that's one of the reasons we're studying is to really understand it. But from a market standpoint, it's a very interesting area. And in fact, I've briefed this to a few contractors that have been like, whoa, this is going to change things. So anyway, thank you, Sarah.
Can I say something real quick or not really? Is it too late? Can I make
Well,
one statement?
If you need a break, I think they're going to start in 10 minutes. So
Oh, okay.
if you want to get up, don't feel, go ahead.
My question is really not a question, is that what's really going on is you're trying to solve a problem that presently exists simply because of the intellectual property laws. If you went ahead and gave more rights to employees, they would end up doing so much innovation, it would be incredible.
Yeah.
But the moment that you gave up that right to scientists and engineer, they will not come to your company and will not give you innovation. What you're trying to do is figure out a short-term solution to a problem that exists. I guarantee you, I was around when New Crash was around, TRW was around, when the government came and all these free research and development people were doing all these incredible innovation that set us apart from everybody. You want innovation? Change the intellectual property laws and you won't have to solve it here. That's all I gotta tell you.
And you're not going to see too many corporate guys clapping at that, but there are actually moves to change some of that. It's years off. We're in a disruptive time. It's interesting. But I will tell you, people want to contribute. They want to innovate. They want to be part of something bigger. And the things that I've noticed is the organizations they belong to typically don't want them to. And they're not finding that there. They say they want them to, but then don't provide anyway. In fact, next time you hear somebody espouse an idea, watch how fast someone tells them why it can't be done. Thank you so much. Sorry for going over.